don't lose too much time. So today we are going to go over regular expressions in detail as far as the basic operations. That in itself does not take too long. However, we will then learn about how to use them in regular expressions. You can basically, when using them in Python, which you can find this page by just searching Python RE, which is the regular expression library, has all the operations you can do for regular expressions in Python. We will, and you can basically, there's two ways we can go about it. We can use the match and pattern objects that you can use in Python, but that's specifically for things if we want, patterns are for if we want to reuse search terms and really optimize stuff, and matches are very powerful kind of answers back from that. So it also has a link to the regular expression syntax, a regular expression how-to document if you want to read that. Also, which basically goes over how to do regular expressions, which I'm going to go over today. Another thing this will go over, another source for regular expressions is if you go to, and this is linked in my syllabus, is going to automatetheboringstuff.com, which is another textbook for Python, and clicking on pattern matching with regular expressions. I will also be working on creating the 6th quiz soon. The 6th quiz will go over Monte Carlo and some file reading writing. So that quiz is kind of an extra quiz because what I'll do is that I'm adding this quiz, but I'm going to be dropping your lowest quiz grade. Make sense? Amul, I see you have your hands raised.
I was going to ask you, what are we doing today? Because, like, what's the plan for today?
Regular expressions.
Okay.
Now, the reason I excuse me 1 second. And after regular expressions, I will be teaching some more. Over the next couple of weeks, I'll also be teaching some more programming concepts, such as searching, sorting, and object-oriented programming. I did post the quiz corrections. You can find them in the announcements. I'll probably just end up going through them anyway, but yeah, please post your correction requests so I can get to them.
So do we have to do quiz 7 or
6?
Yeah, 6, sorry, quiz 6. If we don't do quiz 6, is that the one you're going to drop, or
Yeah,
will you drop a different one?
The grader, I don't drop it, so I don't physically figure out how to drop anything. That's all all Canvas. Canvas will drop the, I set up the rules for Canvas, and Canvas figures out the most advantageous way for it to drop grades for you. Make sense?
Yeah, so there's going to be one, so we're going to take 6 quizzes, one of those are going to be dropped.
Yes.
Okay, cool, thanks.
Yep. So this quiz, if you're happy with your quiz grade, this quiz is completely skippable. Labs, I'll be dropping. That will be because of yeah, the labs will have at least one dropped. I'll probably drop more because that also includes the in-class exercises as well. The labs from the regular expression lab is an optional lab. It's worth 15 points. However, the things I'm covering today for that extra credit lab are also going to be super helpful on the final exam. Yes, you can always redo your exercises. All right, and with that, I'm going to go ahead and get started on regular expressions. So just know that this document over here, the Automate the Boring Stuff textbook, free online, has chapter 7, talks about all the stuff I'm going to do today, as well as the Python Regex how-to document, tells you how to use regular expressions. So if you need any more elucidation on those things, then I can provide them. So regular expressions are those super powerful find replace tools. Now, last Thursday, what I talked about was the issue that Jeb Bush had when he released a bunch of email documents. So sure, I can share links, but here is the how-to document. Here's the documents for how to use regular expression in Python. And here is Automate the Boring Stuff, Chapter 7. Okay. So I explained that basically Jeb Bush had an issue with releasing his emails as part of Florida sunshine laws. In other words, Florida man striking again. And he accidentally did not redact or his team, because he probably just authorized it. His team did not properly redact his a bunch of things like social security numbers that were in the email, even though those were protected under law. And again, I'm not picking on Jeb Bush specific because he's a Bush or because he's a member of any particular political party. I would be lying to say if I did not have my own particular political leanings. I'm not, but he has been the most recent example of this. And the next time that something happens like this, that will be the most recent example, and I'll use that politician. So that said, Jeb is still meme-tastic as a presidential candidate or electoral candidate. If you have not seen the Jeb meme, you should look it up. It's pretty funny. So the issue is that basically you can't just simply use a simple Control F, find a social security number to find a social security number. Now, again, for those of you who don't have to deal with them too often or aren't living in the US, the social security number looks like this. And I'm just kind of making it up. Apologies if that is your social security number. It looks like 3 digits followed by a dash, followed by 2 digits, followed by a dash, followed by another 4 digits. So 3-2-4. Make sense? And what we learned is that regular expressions give us some tools to do this. We can specify, rather than matching a specific digit, that I want to match, and the parts that I'm typing, by the way, are the important parts. The parts between the slashes and the G, not really important. So the D means I'm going to match a single digit. And if we zoom in, we can see that each individual digit has kind of been highlighted. If I do 2 Ds in a row, we'll see that that means that that's matching any clump of 2 digits. So 45, 24, 45, and 45. Okay. And here it's matching 3 in a row, 3, and then 3. So it finds anything that can match this. So to match the full social security number, that's just simply 3 digits in a row, followed by a dash, 2 digits, followed by a dash, and 4 digits. Most characters, if you pump it into a regex, it's going to match itself. For instance, if I ask to match 45, it's going to find all the 45s in here. If I put in 4, it's going to highlight all the 4s. Everybody see that? Just like in Python, we can do /n for a new line. And slashes have a special meaning in Python, in regexes. Yes. Is that a question? Otherwise, I'm just going to mute. Okay, so this would match any kind of social security number. It doesn't matter if it's this one or this one. And notice it doesn't highlight it until it's completely done. Or, you know, it doesn't matter if it's part of a bunch of gibberish as well. Right, it finds it. It's fine. It's just looking for any sequence of characters that match this. This gives you the idea that these are powerful. That being said, regexes at their core are no more complicated than the machines than what are called discrete finite automata, which are essentially like things that you can just stand. They're no smarter than the machines that basically automatically open and close doors for you. They just simply observe state. All right. They're no more powerful than a flow chart. That is literally how powerful regex expressions are, which is both amazing and terrible. Okay, so let's go ahead and see what can we do with regular expressions. Let's go ahead and get some nonsense text. let's go ahead and go novel without letter E. So this is so Gadsby is a novel that was written in 1939. It was a novel without the letter E. I wrote the entire novel without using E once. Just one of those kind of weird things. Let's see, can I get an excerpt of it? So let's go ahead and grab an excerpt of it just to dump into our text so we can use it. Okay, and we're just going to dump it in there. So here I can, so there's a couple different things that there are some special characters, first off, that just don't work the way you would think they would. Words like, you know, an actual word made up of text that works like the way you would expect. All, right? If I type in and say I want to look for all, it's going to find all here and all in practically, just like you'd expect. But there are some things that we have to consider first. The first is the dot character. And notice that once I put in a dot, everything got highlighted. So to answer yourself, Corrine, to answer your question, this is 1939, which means that basically he was very, very bored and did not have TV. This is what happens when people don't have television. Is that they come up with
E is the most commonly used letter in the English alphabet.
Which means that you can't use words like the, which means you can't use the article the, and that does make it challenging. I believe he said his most he said that let's see. I think it was just part of a challenge, and part of it was like using he avoids using words as best he can. Yeah, he cannot use the hardest thing was using the ed suspect. So instead of doing walked, he did walk. Probably not. I have no idea if it's any good. That's irrelevant here. All right, so here the dot is what we call the wildcard character. It matches anything, any single character. So ... means any kind of 3 characters. So here it matches quote if space yo uth comma space t. And notice that it matches anything that's not a letter. Right? So, and here, a nice thing about this tool is that it tells you everything over here, matches every character except the line break. So, okay. So that's just, so what if I want to look for a period though? If you want to look for a period, again, we make use of the escape character to say that I'm going to use /dot to find a literal period, if that matters to you. So if I wanted to find, let's see, another thing I might want to do, I look for is let's go ahead and say, so let's introduce another kind of thing. Besides dot, we already saw that we can look for any kind of, anything that's a number, right? /d was anything that is a number. Likewise, there's there's 2 other things like that. 3 built-in character classes. /w for word characters. So this matches anything that is a letter and an underscore. Why an underscore? Because this is useful in computer science, and in computer science, often we use, if we're making variables, the underscore often takes place of a space. Make sense? So numbers, so digits, words, and any guesses is what the last one is? /s matches space. Punctuation is not a bad guess at all. So /s matches any single character of punctuation. This matches any single character of lettering, word characters. So capital letters, lowercase letters, and and the underscore character, and then the digits over here, right? So let me just go ahead and enter in some digits to say 1, 2, 3. So there we can see that each of these single digits are matched. And you could just simply say, if I wanted a 3-letter word, I could go like this, right? Oh, W also matches numbers too, because any word character, alphanumeric and underscore, okay? So here, anything that is 3 long matches. All right, so the other really cool operations that we get is the plus operation, which notice what happened is kind of subtle on your end. What's happening when I'm entering the plus. So when I put in the plus modifies the thing before it. It says at least one of. So here, it's basically saying anything that's that's at least one character long, one alphanumeric character long. So we matches if the whole word youth throughout all history had a champion to stand up for it, right? So it's basically it's matching as big of a word you could. So already you could use this regex in Python to basically get all the words in a line in just the words. All right. Similarly, there are inversions, which are also useful. So /d, if we capitalize it, gives you the knots. /w, anything that's not an alphanumeric character or an underscore. And finally, S, anything that's not white space. So again, so these are just built-in things. S for white space, word characters, and digits. So here, and the plus, and then we learned about the plus character. The plus character modifies the preceding character where it says at least one of. So here we're matching anything that's at least one L. Would these work in idle? Yes, when you're using when you use the regular expression library. We're going to show you how to use these the Python regular expression library after we learn a bit of the syntax, because you got to use the syntax to know how to do it. Okay. So of those things I just told you, what is the most important thing? The plus thing was the most important. Plus means at least one of. Okay. So here is another kind of useful character. So American spellings and British spellings can be different, right? So for instance, color, depending on whether you're coming from a Commonwealth nation or you're in the States, can be different. So if I wanted to find color, right, if I'm control Fing for color, I could find the American spelling, but not the Commonwealth spelling. So how would so regular expressions makes that pretty useful. There's a way I can do this. And I can put in the U and I can specify that this is an optional character. So plus meant at least one of at least one U. That's not what we want here. We want 0 or 1 U. So question mark means 0 or 1. I'm not sure if I think it does. The S does tabs. Not sure about new lines. There's also one more called the clean star, which we'll get into, but that's at least 0 of. And those are useful for kind of more mathematical, kind of abstract concepts, but they're still useful. So let's go ahead and say we wanted to find anything that was, so let's see. Now I'm just trying to think of a good example. So we'll go ahead and work with some. So I'm going to keep this here. And I'll go ahead and start off with some things. All right, so I went ahead and did no Batman. I don't know if I did it enough times, but okay. If I type in nah, that's going to get one of the nahs before Batman. Okay. If I do 2, right, that's going to grab any. If I do nana, it's going to find 16 of them, right? 1, 2, 3, 4. No, 16 characters, 8 nanas, 8 nas. But I can just simply do plus to say, hey, I want, well, it's going to match 1 N followed by an A and at least 1 A. To do more than one character with the plus, I'm going to use my parentheses like this. Makes sense? So so here what I wrote was a capturing group, which I did. I put multiple tokens together and then a plus. So this catches the entire string of na. And then I could do a space and Batman to get Batman in there. If I didn't have this, it would just simply catch na Batman. Now there is, again, some other thing I could do. I could do, again, I could do the plus operator here to catch as many as I could. And then I could do this. So what does this catch? Well, it's going to catch, let's see. Let's see what this will catch. So first things first, let's go ahead and copy paste this line. All right. So first, let's go back to this. Okay. So na plus space Batman, we get as many nas as we can connected together, plus a space, and then Batman. Similarly, so it matches this one, this one, this one. It does not match this one because we don't have a na followed by a space, followed by Batman. There's no nas in the fourth line, so it doesn't capture that. Whereas we've got one solid na, so we've got at least one of them, followed by a space, followed by a Batman. Now, and let's go ahead and do one more. Again, over here, we have no na in front of here, so this does not get captured or found. If I do an asterisk, that becomes what we call the clean star, which is spelled K-L-E-E-N-E, which I just put into the chat. K-L-E-E-N-E, the clean star, which we can just call the star, and almost everybody does. So what this says, it says, so plus is at least one of. Star is at least 0 of. So we're going to add one more line here just to make it. Actually, no need to add one more line. So here we find na because we have at least 0 nas followed by a space followed by Batman. We have na, right? And again, it's matching all of the na over here because it's in the parentheses. The parentheses are what let us get the entire na rather than just a single letter. Matches this. Now here's interesting where it doesn't get the N because you have to have an NA, but it matches space Batman. Now it matches space Batman because it's saying, I didn't find any, but that's okay. But I did find I found a space Batman, and that's all we need to get a match. So it found space Batman, and a single na caught that. It doesn't work for Batman though, because even though there was no nah, that's okay. There wasn't a space in front of Batman. If I put a space in front of Batman, it's going to find it. Does that, am I making sense so far? Okay, so now what about, so what are other what is the other kind of use, the other most useful operation? So the plus was kind of super useful. The other things I would find super useful are the curly brace operations and the quote and our brackets. If you're going to remember anything, remember how these three things work. They will be you can pretty much do everything you need with those, or the vast majority of what you need with those. Okay. So what are those things? Only one of which I've introduced. Well, you're like, okay, /W was great, right? /W, which gave me all the alphanumeric characters, are great, but what if I just want the alphabetic characters? I don't want 1, 2, 3 or anything like that. Or maybe I just want the numbers, or /D is great, but my school IDs are only numbers. The first 3 digits are only numbers between 1 and 5. And so I need to validate that. So that doesn't, so how do I write something that only accepts those? Well, fortunately, that's where where these come in, are brackets. Brackets allow you to make your own class, which is possibly the most useful thing in here. So what I just wrote over here is my own custom class that matches an A, an E, an I, O, or U. So it says find one of the things in here, A, E, I, O, U. In other words, I wrote something that says find a vowel. So, and if you note, all the vowels are now lit up in here. If I wanted, and of course, because this was written without the letter E, removing E has nothing in here. But if I remove the O, suddenly all the O's are gone. Make sense? So you can make your own character class, which is pretty cool. Okay, and then of course you can combine this with anything you want. So anything where we have multiple vowels in a row. So OU, this matches OU to get all together, it matches the A. So here, right, we'll see it matches A, E, I, O, U, I, O, I, U. Okay, and then so here it's matching basically any series of vowels. And so this is any vowel, at least one of. That's cool. Okay. I can also, just like I did with the character class, I can invert this, which is really nice. And what this did is that this is highlighting anything that is not an A, anything that's not a vowel, which is pretty cool because guess what it just did? It highlighted everything that's not a vowel. All the vowels are unhighlighted. That's pretty useful. Okay, well, what if I just want the letters, right? Like, oh yeah, everything in here is case sensitive. Unless you explicitly say it's not. So now what if I want to just find letters, right? I don't want alphanumeric. I want A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z. But I can say that much quicker than I can type it A, B. Yeah. See what I mean? No, the plus did not make it order sensitive. This is any one of in any order. Now, so what I can do here to find any letter A through Z is I can just use the dash here in a special kind of context. And this gives me any letter A through Z. So this gives us, this highlights any single letter A through Z, and this highlights any series of letters that's made up, any series of characters that's made up of the letters A through Z. So youth without the comma, all history. Notice that it did not include the I. If I wanted to get capital letters in here too, easy to do. A through capital Z, capital A through capital Z, lowercase a through lowercase z. Or if I want to be really cheeky, I can do that. And it understands that you want all the letters. Notice it says matches all the characters from character code. It's doing it through ASCII here, but it's not too important. Point is that you can create your own classes. What if I want to just match punctuation? Let's say, now notice inside here, I don't have to worry about using escape characters to find the punctuation for the dot. Inside the brackets, it interprets everything but the caret as normal, except when the caret is in the first position. If the caret's anywhere else, it doesn't care. The caret in the first position here means that it is a negated set, meaning that, look, we want anything but those characters that I just typed out. Okay. So for my, no, there was no comma. So let's go back to the Social Security example again. Here's one Social Security number, and here is another Social Security number. Except they're not really Social Security numbers, because of course they're not, I hope. Okay. So if I wanted to, I can, even if I don't remember how /d works, I could brute force this thing by going 1, 2, 3, 4, 5, 6, 7, 8, 9, create the character for that, and just do 1, 2, 3 dash 1, 2, 1, 2 dash 1, 2, 1, 2, 1, 2, 1. There we go. And do it like that. That's a bit long though. So let's go ahead and shorten this up. So like we learned, this is, oh yeah, Social Security codes can have zeros too. So yeah. So one thing we can do, as we learned, is we can do, is that we can do a dash to go up through stuff. So 0 through 9 for all the stuff from 0 to 9. So I can copy it like this: Control V, Control V, Control V. There's 3 of those, followed by a dash, followed by 3 of the, followed by 2 of those, followed by a dash, followed by 4 of those. Great, that finds any Social Security number, right? I could have used /d here, but I'm pretending I forget what /d is and somehow I can't look it up. Okay. All right, can we shorten this even further? And the answer is yes. And this is why I say you don't really have to remember the other things, even though it's useful to remember the plus, you don't have to, because you can manually create, and same with the character classes. You can manually remember that, but you don't have to. You can create your own. And that's by using so brackets create your own character class, curly braces create your own quantities. Good information, Corey. But for the most part, Social Security numbers don't have any kind of, they don't have any checksums or anything that make them, that basically check the numbers against itself and against a formula to ensure that it's valid. Jeez, why am I yawning so much? All right, let's go ahead and get this. So what I can do with quantity is that I can put a specific number in here. And so we'll see. So this works just like the plus and the clean star. It specifies a certain amount. So exactly 3 of the preceding. So exactly 3 numbers followed by a dash, followed by exactly 2 numbers followed by a dash, and followed by exactly 4 numbers. We are doing regex. So we can do that. So this over here is a really useful tool for specifying quantity. But I said you can make your own, like you don't have to worry about certain numbers. So let's you don't have to worry about remembering the plus or the you don't have to remember about the plus, I said, and you don't have to remember about the clean star. So for instance, I can use this to find 2, exactly 2. But what if I want to find 1 or 2 L's? I want to match anything where there's 1 or 2 L's in a row. I can use this, where basically I've got a range, matches between 1 and 2 of those. So here, if I put a bunch of L's together, it's going to match, as you can see, 2 of those. I can then say like, I can match anywhere between 1 and 4 L's. Just do 6 over there. You'll notice it did 4 L's and then 2. So, which brings up a good, this is a good point to mention that regular expressions are greedy in the sense that they'll try to match as much as possible, which is why we end up with a group of 4 L's and a group of 2 L's rather than a group of 6 individual L's. So this matches anywhere between 1 and 4 L's in a row. So it matches this, matches this, and then it matches this, and this is in a separate group because it will match this part because it's, followed by this. So because, 4 is a subset of 5. If we want to leave it unbounded, we can just simply leave that second part blank, just like we do for a slice, and it will say, and this says, I'll match at least 1 of this. Another thing I could do is I could say, let's see, you can also put in 0. You can put a certain minimum in there. Matches between 0 and 5. Pretty cool. Does not work the same way here. No, it does not. If I wanted to match anything that was not an L, I would create a group like this. Anything that is not 5 L's in a row. If you wanted to make you'd have to make a negated set around it. So a more common example might be something like if I'm trying to match, again, A-I-O-U, and I want to highlight anywhere where I have 2 or 3 vowels in a row. And we see that I have 2 vowels in a row. So with that, we know enough to be dangerous. And by be dangerous, I mean fun. So let's go ahead and I'm going to stop sharing for a second. Well, actually, I don't need to stop sharing. I'm going to go into GitHub. Documents, GitHub, and we're going to start working in Python. Classroom, ITP. 1. We are not submitting anything. For the most part, I'm going to be lecturing from now on. There will be occasional exercises, but for the most part, especially for today, I am lecturing. And I'm going to be showing you how to solve something that we're going to see on our exam, most likely. So text file, we're going to call this SSN social security number.txt. You can call it something else, but I'm calling it SSN for social security number.txt. And I'm going to load it up with social security numbers and stuff. With Visual Studio Code. Okay, trust. My social security number is 1, 2, 3, 4, 5, 6, 7, 8, 9, which would be really amusing if it was. Again, it is 3, 4, 5, 6, 7, 8, 9, not 9, 8765432 Okay, which is also a valid social security format. Okay, so we are going to use this file as the basis for our text doc, as for the basic of our operations today. So I'm going to create a new file called regex example.py. Yes. Okay. And so now to use regular expressions, I'm going to import RE. You can do this in this, and to do this, basically we do this in so yeah, RE is not accessible by parlance. That's fine. So RE is what we need to use regular expressions. Okay. Now there's a lot of different operations we can do that are built in for Python for regular expressions. But first and foremost, let's go ahead and open our file. Open ssn.txt.
What's
Right.
RE?
RE is short for regular expressions.
Gotcha.
We open in read mode, and data is equal to this, and we're going to go ahead and say text is equal to data.read. So now it's all in there. Print text, just simply to make sure that I am not. I just did something annoying. Give me 1 sec. I thought my function lock was on and it was not. Go. Because I rely on control F5 to run my programs. So there, that reads the file and it prints out all those social security numbers that we don't want to get, read. That's not actually my social security number, of course. That's just simply the numbers 1 through 9 typed out. So now how can we go through this and find those things? Well, there's a couple ways we can do it. The first thing we can do is that we can, if we know we're going to be using a regular expression a lot in a specific program, what we can do is we can compile a pattern. And what that looks like is this: SSN pattern is equal to re.compile. And then we put in the appropriate regular expression. But honestly, that's a pain. And that's, even though that's the way it says it wants you to do it and the way you're supposed to do it, honestly, with what you're doing, that's only if we really need to optimize it. There's nothing stopping us from calling these things directly in our regular expressions using the library. So let's go ahead and I'm going to just show you re.findAll, which takes in two things over here. I'm going to start out simple. re.findAll pattern string. Okay. So the string I want to search, first off, it needs to exist first. So pattern. So the string is the string that we are searching within. So that would be text here, right? We're looking inside text to find it. The first argument is, what is it that I'm looking for? Well, I want to look for a social security number sequence, which would be /d, 3 Ds in a row, find minus a dash, and 2 Ds dash 4 Ds. However, I should note something here, which is kind of just something to be very sane about. And let's see, what does this return? It returns all the strings inside this that match that. And it finds them just fine. However, there is something I want to be cautious about, because notice I used a slash. What is a slash in Python? it says it warns of an escape character. Which could be a bit weird if I was trying to find something. So it's very good practice, and note over here when it's looking for something that it has this weird R in front of it. Whenever we're dealing with regular expressions, whenever you're typing one out, the practice is put in an R in front of it. This stands for raw string, but you can remember it as regular expression string. This stands for raw string. And what it does is that it says, you know, those crazy things like /t, which looks for a tab. I don't want to look for a tab. I want to look for literally /t. And this prevents you from having to do something called double escaping, which is this, which gets annoying really fast. And you have to do in other programming languages like Java, because to escape, when you escape an escape character, that means, oh, I want a slash. A Python, so if I do it like this, notice that it will find those because I escaped the escape character, which meant this was a slash. So long story short, when we're dealing with regular expressions and the kind of the pattern you want to look for, use an R in front of it. It will save you a lot of grief. That stands for raw string, or you can remember that you use raw strings for regular expressions. That means that I just simply interpret every string in here literally. Okay. So I just found all of those social security numbers in there. I found 1, 2, 3, 4, 5. I found 1, 2, 3, 4, 5, and I found 9, 8, 7, 6, 5. Okay. But okay. So let's go back to my question on the exam. Or a question I ask on exam. And the question on the exam I would typically ask is something along the lines of this. I want you here, given a file, and I do provide a file on my exams, so you can test it. And I also provide a sample output so you know what you're supposed to be, what your goal is. I'm going to say I would want all these social security numbers to be replaced by redacted. So I would want my output to kind of look like this. Does that make sense? I'd want to go from this to the redacted form. Okay. So now you can imagine that you can do that without using we can do that technically without doing any we can do that without how to say, I'm sorry, 1 second. We've got to turn on this light. We can do that without regular expressions. It's just a pain. And that my pause there was just kind of thinking, wait, how would I do it? I would just have to iterate through but then I'd have to check each character. And if it's a number, I'd want to check if the next sequence of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters followed that specific sequence. And I'd have to check each of those characters kind of individually, which would be a pain. So no, using regular expressions, you'll see what we'll do that. And on the exam, it will be something like this, where I'll say it's, like 5 points for, 5 points for opening the file. For reading the data, 5 points for writing the data to a new file. So 5 points for successfully reading it, 5 points for successfully writing it, 5 points for finding all the social security numbers. And then I'd say if it was 20 points, I'd say 5 points for replacing all social security numbers. And this rubric would be in front of you, just kind of letting you know the steps you have to take. So as it stands, we have just gotten 5 points on the final exam like this, because we've read the file, right? These 2 points, boom, 5 points on the final exam. Boom, no problem there. we can writing a file isn't too tough either. I believe I went over it in the videos, but let's go ahead and just show you how to do that. To create a file, we'll just simply say output is equal to open. And we do a write instead of a read. And this will overwrite any file that has the same name. And I'm going to give the name of ssn output.txt. You can call it whatever you want. I'm just calling it that. And then what we do to write is that, let's say it's text that we want to write out. We'll say output dot write text, and then we'll say output dot close to let the computer know we're done with the file and it should finish writing it. So I run this, boom, boom. We run it. Notice that I've got and now let's see, I've got a SSN output over here. Let's see. And it's the same as our input, of course. I'm working in the Spring repository. That's slightly annoying. Let me go ahead and just move that. So let me go ahead and SSN, that shouldn't be too tough because I'll only have so many. Yep, move these guys. And now we'll move them into fall because I'll not have one. Fall 2021 ITP. Yeah, interesting. Whatever, you'll go and sit right here now. So trust. There we go. So we've got our file. Trust works. Okay. So it reads it, no problem. No such target or directory, of course, it's saying, because what because here I was using ssn.txt. I accidentally copied the wrong file. Doesn't matter. Yep, I copied the wrong file. Okay. Oh, I called it regex example. That's why. Come on. I'm sure you can just copy it. There we go. And we'll just move you right back where you were. Sorry about that. I'm not the most organized one, but I do care about my organization. All right, so let's go back to this. So we've successfully added up to 10 points on exam if the question was remove all social security numbers from a file. Okay. So I'm just telling you this because you're going to see how easy these kind of questions are, especially to get partial credit. So next thing we need to do is that we need to find all these numbers, which we did with the find all. But if we want to replace them all, we've actually got something for that. We've got one function that will do that. This wonderful function called re.sub. So, let's go equal to re.sub, and sub takes in 3 arguments, mandatory, and then there's some other arguments that we can put in if we really need them. The first argument is the pattern that we want to look for, right? So what we want to look for, which is the social security number, The second pattern we want to look for is what are we replacing it with? Well, we want to replace all the social security numbers with redacted. So that's what I put there. And then what am I looking at? What am I trying to remove? Or what am I searching? What is the corpus of text I'm trying to look at? That's text over in this case. So all that I have to fill in is now this for a social security number, which is 3 digits in a row, followed by a dash, followed by 4 digits in a row. So 2 digits in a row, followed by a dash, followed by 4 digits in a row, right? This is 3 digits. And then it doesn't going to change anything quite yet because isn't really going to change anything quite yet. Because I didn't tell it to change anything. Instead of writing out text, we're going to write out redacted. And so now if I go to our social security number output, we see that we have completed the question. We have successfully removed all social security numbers from this and just social security numbers. All right. So let's go ahead and now that you're still fresh and just learned this, let's go ahead and look at one of the exam questions I gave for reals in fall of 2020. How's that sound to everybody? Because I know the biggest anxiety students have about big exams is the fact that like you have no idea what's going to go on. And I'm trying to tell you, these are the kinds of questions you're going to see. It's going to be a different question. But if you know the skills and the problem solving, you're going to know how to solve it. And it doesn't, and notice how short this program was to do this. It was the import statement. This is all we had to do to read. Yeah, this one probably is going to be more complicated, but that's doable. And this is certainly, and knowing to redact it, that certainly worked. If I knew how to do this, that's at least worth this part, even if I don't know how to do the regex or the full regex over here. I try to grade fairly according to the rubric. That's why I have a rubric. So I know how much, where to give the points. So let me go ahead and look. And I have to look in previous courses. All courses. I believe I called that one just Python because it was weird. Because I was weird that semester. So Python. Yep. And I'm not sharing the whole screen because I don't want to accidentally, share everything. Yes, this lecture has been recorded. Okay. So here is question 1 from the final exam of the previous of last year's exam. Now I should mention a couple of things here. You notice that there are 5 questions. I said there's 3. There's really one of those questions is kind of a survey-ish question, and the other question is a place to upload your files. So here, in all its glory, is this question, which I will just copy, which I'm going to copy and paste into here so I don't have to worry about accidentally going down and having to write new questions. So Control S, exam 2020 regex py. I'm going to go ahead and triple quote this so that I can just drop this in. So, and then I'm going to do view word wrap is on. Okay. And then I'm going to get the input file, and then I have to get the input file because I provided a file. Okay. Right. When I'm editing, annoyingly enough, what I have to do is control click, I think, or no, shift click, no. What a pain. Sorry, give me 1 second. There we go. So here is our, we're going to call this exam. I'm going to call this q1.txt because that's what it was. It was question 1. Okay. And then its output, now I can close this, looked like this. So the input was Professor Rosen's personal email is prof.andrewrosen@gmail.com. All emails sent to TUG85861 at Temple or Andrew.Rosen at Temple are redirected here. He is not this TU1, or is it TUF? Although that would be amusing if that was the case. And my output was basically everything that was a TU email was redacted, which we'll get back to. So the exact question was, write a script or function that, given a file name, reads the contents of the file and creates a new file with all the TU addresses removed or censored. A TU email is an email like mine, TUG85861 at temple.edu. A TU email starts with the first, with the two letters T and U, followed by another letter and 5 digits, and then finally at temple.edu. For this input, a correct file would yield this output. Grading. And so the input over here, and then the output, right, is remove the anything that started with TU that was an email address. So 5 points for reading the file, 10 points for correctly identifying TU emails and only TU emails. That's another thing. You don't want your none of that smart alecky of basically just redacting the whole thing. Just I only want you to match the TU emails. 5 points for successfully writing a new file and 10 points for moving and redacting the TU emails for the new file. So how do we do this? So first thing we need to do is that I'm going to import RE to make this as easy as possible. The next thing I can do is that I can start, the hard part is like figuring out the regular expression, but we can work on that. Let's just go ahead and say the pattern is equal to, I'm just going to put TU there for right now. Don't care, right? I want to get everything else. I'm going to work on everything else, but this part, but the part where I only identify the TU emails. So let's go ahead and read the file. So because this is dependent on me opening this file, right? I mean, yes and no. If it looks like you're doing it right, then you'll get the credit for it because I'm not going to run all your code on everything. This is for you to test your input and output. So open data is equal to this, and then text is equal to data.read. Okay, that's 5 points secured. Not bad. Okay, correctly identifying the TU email. Okay, we'll do that in a second. 5 points for writing to a new file, and then 10 points for removing and redacting the TU emails. So let's assume I correctly do this part. Let's go ahead and do the removal and redacting. RE, so I'm going to put this as basically redacted text is equal to TU. I'm going to say, sorry, I'm going to use re.sub to do that. which substitutes a pattern. And then what I want to remove it with, I'm going to go and say redacted over here. And then I'm going to do, and then I want to search the text for that. Okay. Oh, I should probably spell that correctly. All right. So this will be 10 points according to this rubric. Probably not on the actual exam. And then finally, let's go ahead and do the writing a new file. Okay. And why am I going over this? Because enough people get this wrong still. That's why. Like, I will give you, I give classes enough help until over successive semesters until I see that like everybody's getting it right, at which point I know I can reduce on the help that I'm giving. Okay. But I'm just trying to emphasize just kind of how useful this function is. So redacted. And so now what I gotta, so I'm going to call my output Q1. So I know it's for question 1.txt. I'm going to write to it. And I'm going to just call it the variable for doing that output. Then how do I output text? It's 2 steps. I write it. I tell it what I want to write. And I only need, and I'm doing the entire text all at once. So I'm just going to do that. Just dump it all in there. And then output dot close to just be done with it. Nice, right? Okay, so if I go ahead and run this, actually, I get something already. So Professor Rosen's personal email is Prof. Andrew Rosen. All emails sent to redacted G85861. It removed anything that there was a TU of and replaced it with redacted. Okay. So now let's go ahead and work on this one. So we need a TU email addresses. So all TU email addresses are as following. TU. So this is the ones that you get assigned as a number, not like the aliases like andrew.rosen@temple.edu. So 2 numbers and then a letter. So, and since it's a TU email address, it would be lowercase. So I'm going to go ahead and do that. So 2 TU and then a letter. So how do I do a letter? I'm going to make a character class for that. A through Z specifically. Make sense? So that's going to get TUA, TUB, TUC, TUG, TUF, so on and so forth. Then it's followed by 5 digits. So notice I'm just constructing this piece by piece. Let's just be, let me type out 5 specifically, 5 digits specifically, because remember, humans are prone to error, right? And if I'm working on this, I don't necessarily know if it's sometimes hard to tell at a glance when there's 10 characters, is that 5 grouping? So I'm just going to go 5. I'm also going to remember, since I'm using a backslash, to make this a raw string, because Regex is used raw strings like this. Okay. And notice how it's highlighting properly, which is great. And then we need the @ symbol, and then at temple.edu, except the dot has a special meaning, right? Which means any character. To get an actual dot, we do dot like that. The R is to ignore that, is to treat this literally. If without the R, in order to do a dot, I would have to do \\\. This is to treat it as a raw string. It basically says, hey, these you use them when you're using regexes and you want the string to be interpreted literally for what it is, right? Let me kind of just show you in idle the difference. Okay. S is equal to /T A. Print S. And notice it printed out the A tab with one tab over. But now let's suppose that I do S is equal to R T A. Now that saying that this is the R in front of us in front of the quotation marks means this is a raw string. And so what it does when I want to get S is that it's going to print out, say you wanted a backslash, a T and an A. It says literally interpret everything I'm reading, which I need to because the regex uses its own internal engine for doing this. So that's the regular expression I need. Run it, check my output, and we notice that only the emails that start with TU letter and follow the format are redacted. But andrew.rosen@temple.edu is not redacted, nor is the prof andrewrosen@gmail.com. Again, total number of lines here. 1, 2, 3, 4, 5, 6, 7, 8 lines. Yeah, I can give you the pattern. Why is there a slash before the edu? So the dot, again in regex has a special meaning. Dot is the wildcard character, meaning that it matches anything. So if I were to put in this would match dot temple. This would match tample. This will match tumple. It matches any single character. So now, if I do this to get a literal dot, when I'm looking for a dot, I just do the slash to kind of tell it to ignore the special meaning that the dot normally has. Oh, as in the whole string that needs to get redacted. So my target. So yeah, you can test the target over here. Here's my target. So you can go ahead and test that for yourself. So that's the kind of thing that I like to kind of ask about for these on this exam. So regular expressions are super useful. So let me go over and again, to give you more incentive, let me go ahead and point you to the extra credit. Okay. And then after that, class will be dismissed. Because, you can only pay attention to me for so long. I know I'm so entertaining. I'm amazingly entertaining, but I know, and how we're pushing it. So let's go ahead and take a look at the regex modules, the regex assignment. So notice it's worth 0 points. So if you complete it, it's worth 15 out of 0 points, meaning that 15 points is just added straight on top of all the other homework points you get. So now only the first page is required, but the other pages can be very useful to do. So the first one is regex dictionary, which you will use this document, which is a dictionary file. It's got now this is what's used by a computer for spell checking. As a result, it's got all the words in it, all the words in the English language that you would want to spell check, including the ones that are not very nice to say. So just be aware of that. So that said, that shouldn't really cause any issues, but I'm just letting you know it has all the words that you would expect to find in a dictionary. So what you're going to do is that you're going to use regular expression to answer these 10 questions and this file. You're going to, I like animals. Nope, you can use, so two good questions. What is the weighted group of grades going towards? This is going to your active lab assignments, the 30% done by labs,
And you are dropping one lab?
yes, I am.
Okay, thank you.
And then Somebody else asked, do I have to use visual code? No, you could do this in idle instead. I just like visual code a whole lot. It's a lot. It's a lot more, it feels a lot more fluid for me to use. So I like using it as opposed to idle. I like using idle in the beginning because idle doesn't require any additional setup, but you can use whatever you want. I just used the Python extension. I have no idea why that pattern is giving you an error. You might want to check. Oh, because Naila, don't have a space between the R and the quotation mark. Okay. Somebody says, do we have to only do all 4 pages? No, the 4 pages, only the first page. The first page, this page is the only required one. These ones are for extra practice. So, I like animals. How many words have cat and dog in them? This can be done without using regular expressions, but use regular expressions for this. 4-letter words are supposedly naughty. How many 4-letter words are there? I'm scared of pyramid schemes and schemes in MLMs. How many words contain hun in them? Do more words end in ing or ion? And here I will, and how many words contain a q not followed by a u? Now there is one more thing I need to, and yes, I'm going to redo the auto grader, and there should be another import of grades this weekend. Okay, there's one more thing I need to kind of just show you with regards to stuff, which is the which is, I don't want pattern settings. I want here, there's a cheat sheet here, which is anchors. And this will be useful for going through this stuff. So the start of a string. So a caret at the beginning of a regular expression means the start of a string, sorry, the start of a line, and then this means the end of a line. So notice over here, ABC doesn't work, but ABC over here, well, let's see. Oh, beginning of a string, what it cares about is over here. And let me go ahead and do this flags to just say, multi-line. There we go. You got to tell it how you want it to work. So here, notice that basically if it's at the beginning of a line, right? So this will only find ABC if the line starts and ends with ABC. If you can't review quiz 4, hold on. Let me check. So, all right. Actually, I think that's it for today. So now with regards, you can't review quiz 4. Let me go ahead and check that out. I think I have to release all. I think I have to release the grade. Let's see. Grading. That's where I want to be. Assignment. Quiz 4. No. Okay, I've released the grades. But I'll see about that. Let me go ahead and run the grader on that just to make sure it gets caught. Okay. So I'm running the grader on that. Hopefully it should let you, see what you need. All right.
Have a good one, Professor.
All right. Otherwise, class is dismissed. If you've got questions or comments or concerns, I'll be here.
Do you mind opening up your code again, showing your code?